Hi guys, welcome back. Today we're doing Module 3, Lesson 9, where our objective is I can multiply 3 and 4 digit numbers by a 1 digit number and applying the standard algorithm. Something else I've added to our notes is why this is important. And the reason this is, some of my students have been asking, Miss Kohler, why do I need to know this? Well, here it is. In order to better current multiplication skills and to be able to use these skills in real life problems. As you guys get older, you're going to find that real life problems happen where you do need to use your math skills. So this is where those will come in handy. So we're going to dive into our application problem where it says calculate the total amount of milk in 3 cartons if each carton contains 236 milliliters. So this carton has 236. This carton has 236. Make that look like the 6. And this carton has 236. We need to know how much is in all of them. So something we can do that, guys, that we've been doing for a while. Columns will do 4, 2 rows. So I'm going to do my ones, tens, hundreds column. I'm going to put 1, 2, 3, 4, 5, 6 for my ones. I'm going to put 1, 2, 3 for my tens. And I'm going to put 1, 2 for my hundreds. How many groups do I have? I do have 3 groups. So that means I need to have 3 groups in each column. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. 1, 2. 1, 2. And so now I have 1 column or 1 group, 2 groups, 3 groups that each represent 236. Well, the problem I have here is I have too many. I have too many in this column. And I know this because it's more than 9. So what I'm going to do is I'm going to mark them off. I'm going to mark them off the red one. 1, 2, 3, 4, 5, 6, which we knew. 7, 8, 9, 10. And I'm going to put another dot right here. I'm going to double check that I don't have any more than 9. 1, 2, 3, 4, 5, 6, 7, 8. So my ones column is now an 8. Let's check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh. That's 10. So I have to mark these off because I could also erase them or X them out. But it's going next door. And that leaves me with none in the middle because I marked them all off. They're all gone. 1, 2, 3, 4, 5, 6, 7. So this place value chart showed me that 3 groups of 236 or 3 times 236 equals 700. Something else we're going to learn today is something called partial product. So this is the standard algorithm, or one of the standard algorithms, where you can use this chart in order to do it, and we'll learn how to do it in numbers a little later down the road. Or numbers only, so you don't have to draw dots anymore. So this problem says use the place value chart to model and help you solve the problem below. Use the standard algorithm to represent the problem and solution as well. So what this means is what we already did. So I'm going to put 2 black dots in the ones column, 6 red dots, 1, 2, 3, 4, 5, 6 in the tens column, and 1 green dot in the hundreds column. This blue lets me know how many groups I need. So go ahead and think in your head, how many groups do you need? Yep, you need 6. I'm going to cheat. 2, 3, 4, 5, and 6. And I know this because 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups. Because a group was 162. So I have 6 162s. So now what I'm going to have to do is I'm going to have to go through and figure out how many ones I have, because I can't have more than 9. 2, 4, 6, 8, 10. So this section right here gets an extra dot right there. So that leaves me with a 2 in the ones column. The next step, so this was 6. So I know 6, 7, 8, 9, 10. Puts me another green dot over here. So 2 plus 6 I know is 8, and I'm going to go ahead and add another 2. So notice I'm going to go ahead and group my 10s. There's 4 plus this whole 6 right here gives me another 10 of 10s, which is 100. And then that leaves me with 1, 2, 3, 4, 5, 6, 7 right there at the bottom. Because everything in these green boxes is equal to 10, and it gives me another 100. So let's count our hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I've learned from this is that 6 groups of 162 is 972. I'll go ahead and show you the numerical way of writing this out. You can write it down, but please note that you don't have to understand the first time we do this. So if I had 162 times 6. First thing I'm going to do, I'm going to write it in red so we can see a difference. 2 times 6 I know is 12. So I'm going to put a 1 right here because I know I've got to carry it. 6 times 6 is 36. Plus this 1 gives me a 37. Go ahead and carry my 3 over. 1 times 6 is 6. Plus my 3 is 9. I have nothing to carry over. I've already used those. I can mark them off. And notice that my two numbers actually equal up, which lets me know that both my methods worked here. Alright, same thing. This time we're going to add partial products, which looks very similar to what we did here, except for it's going to look a little bit nicer. So we're going to go ahead and how many ones? 1, 2, 3, 4, 5, 6, 7. How many 3s? 1, 2, 3. And then how many 2s? Or hundreds? 1, 2. Whew. I need 5 groups. That would be my second group, my third group, my fourth group, and my fifth group. That's a lot of ones. That's a lot of tens, and that's a lot of hundreds. Now you kind of see why, as we move on, we're going to want to use more numbers instead of these dots. Dots are fine. The place value chart is fine. But we're going to want to move into that partial product solution. So I know this is 7. So I can mark it off. 8, 9, 10. I'm doing it in the wrong color. Now this is 4. So I can go ahead and mark off 6 more. Because what that'll do is give me another 10. I have 1. 7 gives me, plus 7 gives me 8. 9, 10. Notice I don't even have to count my dots because I can group them in tens really quick, which gives me 5 here at the bottom. Same thing, 4, 8, 10, and then I have 2, 5, 3, 4, 5, 6, 7, 8 left right here. And then the last one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means I have to move all these to next door, giving me a 1 here and a 1 here, and then we cannot forget our comma. So I've already showed you the traditional math to show me this, and I'll still do that one to prove it, but then I'm going to show you standard algorithm. So once again, we're going to put the big number on top. I forgot to kind of tell you that last time. And then we're going to multiply by 5. So notice I just reset the format. It's the same problem. So I know 7 times 5. 5, 10, 15, 20, 25, 30, 35. I'm going to bring over my 3. Make sure I write my ones place. 3 times 5, 5, 10, 15, 16, 17, 18. Mark it off because I've used it, but bring over my 1 from my 18th place, or my 10th place from my 18. And then 2 times 5 is 10, adding the 11, which means I have to carry 1 next door, but I dragged it down already. There's my comma. Once again, they are the same, which means that both of them work. So these two are the same thing, because you'll see that I had to carry over 3 dots, just like I did over here when I marked them off. I had to carry over 1 dot here, like I did when I marked it off, and 1 dot over here, like I did when I marked it off. So you can see that they represent the same thing. Now let's do it. I'm going to create a divide. Partial, you know what? I don't know why I'm doing that. Partial products. So we're going to set it up the same way where it's 237 times 5. But this time it's going to be a lot easier. And here's how I can tell you. So what is this 7 worth? This 7 is worth 7, correct? So that would be 7 times 5. Well, what is 7 times 5? We already said it. It's 35. All right. There we go. Guys, you know I love it when my colors are all right. Now, this is not a 3. It is a 3, but it's not worth a 3 because it's in the 10th place. So that's actually worth 30 times 5. So what's going to happen is I'm going to put 30 times 5 right here. Well, if I know 3 times 5 is 5, 10, 15, all I'm going to do is I'm going to add a 0 at the end of my 15 because 3 times 5 is 15, and I have a 0. I'll move these over a little bit more. And this last one, this 2. This 2 is not worth a 2. It is instead worth a 200, and we're going to multiply it by 5. So 2 times 5, 5, 10. So I'm going to write my 10 here because that comes from here. But then how many zeros do I have to add? 1, 2. So here's where I don't forget my comma. And I add them up. 5 plus 0 is 5. 3, 6, 7, 8, 9. No, 3, 4, 5, 6, 7, 8. Plus 0 is just 8. 1. Don't forget my comma. 1. Once again, all the same answer, but this way, this is how I'm using partial products because this is just a piece of this number right here. That's why it's called partial. Pieces partial. You will need this in your notes. Right here. You need this in your notes. Alright, same thing. So we have 6 groups of 716. So I have a question for you. Would you rather use dots and have to count all them up, or use partial product? Personally, I'm going to do partial product. If you've chosen to do the other one, that's fine, but you are still going to have to write the partial product out. I'm sorry, guys. I'm super mean today. So write my big number on top, 716 times 6. All right. Help you out here. First thing I'm going to write it in red, is 6 times 6. Where I'm getting that is this number and this number. It's right there. So 6, 12, 18, 24, 30, excuse me, 36. All right, the next one. write it in green. This is not a 1. It is not a 1. It is a 10. 10 times 6. I'm going to write it right here. 10 times 6. Well, I know 1 times 6 is 6. Plus I have 1 0 to add at the end. Oh, 10 times 6 is 60. Well, that was easy. My last one is 7 times 6. That one is not so easy, but fortunately I know my 7's timetable song. But remember, this is not a 7. It's 700 times 6. So let's have some fun and sing along to 7, 14, 21, 28, 35, 42. Alright, so I'm going to write my 2 zeros because they're there and I've got to line them up. And then a 42. Don't forget my comma. And then I'm going to add, make sure I write add right here. 6 plus 0 plus 0. 6. 3 plus 6 gives me 9. 2. And 4. There's my answer. Alright. I'm going to help you set it up, but you guys are going to end up being the one to solve it, and you have to raise your hand and let me double check your answer before you move on. So, solve the problem below using the standard algorithm. It says the standard algorithm. It just means a standard algorithm. It doesn't matter if you choose to use the place value, if you choose to use partial product, or if you want to use how I showed you here, which again, you don't have to know how to do this. You do have to know how to do this. That is the main goal today, guys. So, Shane measured 457 milliliters of water in a beaker. Olga measured 3 times, ooh, look at that, 3 times as much water. How much water did they measure all together? So there's my question. All together. So Shane had 457. That's how much he had in his beaker. Okay, let's draw it out, because I'm betting there's a simple way to do it. So here's Shane's beaker. How much did we say it had in it? 457. Well, Olga measured how much? 3 times that. So 1, 2, 3. So there's what Shane measured. There's what Olga measured. How many groups of 437 do you see? I have 1 group, 2 groups, 3 groups, 4 groups. So because I drew it out, I can save myself a step and just go, oh, it's 457 times 4, because I see 4 groups. Shane's 1 and Helga's 3. And we wanted to know how much did they measure all together. So go ahead and you're going to solve it the partial product way, or you can solve it the number table way. But you cannot move on until I have double checked your work. And don't even think you're going to cheat me, because I'm going to come around double checking anyways. If you have any questions, please raise your hand. I know this was kind of a really fast-paced instruction, even though it took 19 minutes. So keep up the good work, guys. Bye.